All right, everyone. So in this video, I'm going to talk about how we can work out what happens when we project onto a line. So we're going to take this vector 1, 0, and we're going to project it onto this line y equals mx. And what projection means, I'm going to draw it here in red, is that we're going to find the point on this line that's closest to this point. Right? And so one way to think about it would be to imagine, we kind of oriented things, I'm going to spin the screen, is if we were to take this picture and orient it so that that line was like the ground, and we were to take our vector 1, 0 and just let gravity have it come straight down. Right? So if we were to do that, we would see where that point landed, and that point would be our projection. Right now I'm going to turn everything back, and we're going to see what that looks like. Let's see if I can do it. Good. Okay. So this point here is going to be our projection, right? And we want to find the coordinates for this point P, right? And in the homework, you're going to find the coordinates for what happens if instead we project this other vector, 0, 1, which is going to be up here. Okay, so this is the vector 0, 1. And you're going to see what happens if you project that point down. You're going to see it's going to be somewhere over here. So you're going to have to find that coordinate on the homework. And so here's, there are a couple ways to do it. One thing you notice is that since it's a projection, this is going to be perpendicular. So you could think about like Pythagorean theorem, but that's actually a little bit tricky. And so what we're going to do instead is we're going to be a little bit clever with vectors. And this is kind of a cool idea. So if I take that vector, or that little line segment there, and I move that around, and I'm going to take off the graph paper because I've kind of lost something. And if I move that around, and I think of this as a vector v, right? Well, v starts at 0 and goes off to, that point v. And what I notice is that my point P that I want, my answer, is going to be 1, 0 plus the vector v, whatever it is. Remember how we do vector addition. We go to 1, 0, and then we go along v. Okay. And so that's going to be a useful fact. And I know one other thing about v. I know that v is perpendicular to the line y equals mx. Okay. And so if I think about v is along the line y equals negative 1 over mx. Remember that fact from high school algebra class that if we have perpendicular lines, the slopes are going to be negative reciprocals. Right? And so what I know about this vector v is that whatever its two coordinates are, I don't know what the coordinates are, but I know that whatever the y coordinate is, the y coordinate needs to be negative 1 over m times the x coordinate. And so I don't know what the x coordinate is, let's call it a, and let's do it like that, okay? So now we have our vector v. Oops. We have our vector v. And what do we know? Well, we're going to have to figure out what that point A is, right? And so now the last step that we can do is let's do it here. So we know what P is. So P is going to be 1, 0 plus this point V. And we just figured out whatever the x coordinate is, let's just call that A. The y coordinate is going to be negative 1 over m times A. And if I simplify that, let's just do that over here, it's going to be 1 plus a, and then negative 1 over m times a. Okay. And now the last thing we're going to do is we're going to notice that this point P, right, which is, we just worked out 1 plus a, negative 1 over m times a, that point P has to lie on the line y equals mx. Beautiful little vector geometry that we're doing here. And so that must mean that the y-coordinate has to be m times the x-coordinate. Right? So that must mean that this y-coordinate has to be m times the x-coordinate. That's pretty cool. Right? And so let's clear denominators and see what that means. So that's going to mean negative a is m squared plus m squared a. And that's going to imply, if we solve for a, it's going to mean that, let's do it over here. So we're going to get negative m squared equals a plus m squared a. So negative m squared is a times 1 plus m squared. And that's going to tell us that a is equal to negative m squared over 1 plus m squared. And so let's put all this into our final answer. So our final answer is going to be that our point P, that projection we sought, is going to be exactly the point where we do 1 plus a, so that's 1 plus this fraction, and then negative 1 over m times a. And I'm just extracting this up here. So that's going to be negative 1 over m. Well, that's going to cancel the minus sign. That's also going to cancel an m on top. And so that's going to be m over 1 plus m squared. And now I can kind of simplify this, do a little bit more algebra. I get a pretty nice expression. Once I simplify, I'm going to get 1 over 1 plus m, 1 over 1 plus m squared, m over 1 plus m squared. And if I want to factor, I just get 1 over 1 plus m squared times 1 comma m. And so at the end of the day, we have a beautiful coordinate of this point. Right? It clearly lies on that line y equals mx because the y coordinate is going to be m times the x coordinate. And so we have figured out what the coordinates of that point P are going to be. And so let's do one last reality check, right? Let's just do a reality check and see if that makes sense. So if I did, let's do a simple case where we know the answer. So let's do a case where we do this, the line y equals x. Right? So this is the line y equals x. And if we take this point 1 comma 0 and we project it up here, well, if we think about what's happening, well, this is a right triangle, and this is 45 degrees, this is 45 degrees, and this length here is 1. And so what should happen? Well, we know from right triangle geometry, this is going to be root 2 over 2, this is going to be root 2 over 2. Right? That's the way we could use trigonometry also if you want. And so our claim is that our answer, our projection P, what does our formula tell us? What our formula tells us at this point should be 1 over 1 plus m squared times 1 comma m. And what is m? Well, m is just 1. The slope is 1 in this case. So it should be 1 plus 1, 1, 1. And that should be the point 1 half, 1 half. And so now, I'll just maybe leave this to you to think about. Is that right? If I have the point 1 half, 1 half, well, it's definitely on the line y equals x. And is it the right distance up that line? In other words, have I gone up the right amount? And I think I have. Because the distance from 0, 0 to 1 half comma 1 half, well, I'm going to do the Pythagorean theorem, and I would exactly get that. And you can also kind of see that by symmetry in this picture, if I kind of clear everything up, that this projection, wherever it is, it looks, I mean, by symmetry, you can see it's right in the middle. of this segment. And so it really should happen when x equals 1/2. And of course, because it's on the line y equals x, y has to equal 1/2. So I hope you have fun working on the analogous problem on the homework. And yeah, have a great day. Bye.